Hey guys, Mr. Palmer here, back with the second thermodynamics problem. I kind of took the same prompt from the last problem I did on this, or the first one I did, changed the approach a little bit. You'll see there's some Lewis structure type stuff and a little more equilibrium type stuff in here. So let's dive into this one. Hopefully if you got warmed up with the first one, this one should be pretty easy for you. Again, we started with the same materials, but you'll notice this time a little bit of a change here. I changed it to go kind of the other direction. I gave you a certain mass of iron this time rather than the iron oxide, and we're going to go the other direction. And I'm asking you something about an enthalpy change again, and we're getting down here into this K value. Okay, so let's start with part 1, or rather part A. It asks you to find the mass of hematite that would be required to make a certain amount of iron. Like we did before, we're using the same thing, except we're going to go the other direction. 154.26 kilograms of iron. And we're going from iron to the iron oxide. Right, so we're going from iron to the iron oxide. Iron is going to be, first of all, let's get our kilograms into grams. It's 1,000 grams in a kilogram. We need to do our conversion to moles. Iron is 55.85 grams per mole. We need to do our mole ratio from the balanced equation. Right, we've got a 2-to-1 ratio. There's 2 moles of iron. Make sure you're putting them in the right location. Right, we're starting with iron, so that's going on the bottom, to 1 mole Fe2O3. Okay. Lastly, we need the molar mass of the iron oxide. If you look that up correctly, it's 159.7 grams per mole. Multiply that out, that's going to give you 2.21 times 10 to the 5th grams. Now it doesn't ask you whether it's in grams or kilograms, so you could put either. That's 221 kilograms. Let's look at our answer. Does that make sense? Yeah, it's bigger. We're trying to get this much iron. We're going to need more iron oxide than we have iron, right, for it to come from. So double check your answer to make sure that it makes sense at the end. Let's look at B, determine the enthalpy involved in this transformation. I've got 154.26. We're going to, do the exact same thing we did before. We're going to start the same way, 154.26. We're going to have to turn that into moles. But we're looking for the enthalpy change, right? That means we got to look at the delta H for this reaction. Now, this number is for 1 mole of this stuff. Right? We don't have 1 mole of this stuff. We have some different amount. So we're going to take our iron, we're going to convert it, right? 1 kilograms, 1,000 grams. We're going to do our mole conversion. We have 55.85 grams per mole of iron. Now you could stop there and just write down the moles of iron, but that's probably 1 point out of this 2-point problem, correctly getting the amount of iron. We need this relationship right up here. This problem is telling us that this amount of heat is coming from this reaction. And in this reaction, there are 2 moles of iron. So I need to use that relationship. 2 moles of iron is going to give me this many, negative 23.44 kilojoules of heat. That gives you 2.24 times 10 to the 4th kilojoules negative, okay, as we multiply that across, because this number was in kilojoules right up there. The sign is important. If you don't have the correct sign, you're definitely not going to get this guy correct. Let's just do the last part here for C. For this first part of the problem. This one's pretty easy. It says write the gaseous equilibrium expression. Super simple, right? Here's your Kp. We're only looking at the gases when we go to write a Kp. Solids are not going to be in an equilibrium expression. We take the products, the pressure of CO2, and we raise them to the power of their coefficient, right, with a coefficient of 3. Carbon monoxide is my reactant, my pressure of the CO, and I'm raising it to the power of its coefficient. The coefficient is 3, it's to the third power. That's a pretty simple 1-point type problems. So A, B, and C together, probably somewhere around 5 points for that, I would expect. All right, I'll be back with part 2 right after.